Hi, my name is Kyle, and in this video, we're going to go over the core fundamentals of using the game framework LÖVE2D. We'll start off by talking through the process of installing LÖVE and getting your programming environment set up. Then talk more about how projects are organized with LÖVE. And finally, we'll start the process of creating a game from scratch. While working on this game, we'll talk about key features of LÖVE, including the core load, update, and draw functions, getting the structure of our game set up with our global variables, drawing shapes and colors to the screen, and reading mouse input from the player. Covering these basic concepts will give you a great understanding of how LÖVE works as a whole. So when you're ready, let's get started. This is going to be a super short lecture because installing LÖVE is very easy. Just go to löve2d.org and the download links are right there. Just click on the appropriate link for your operating system. If you're on Windows, I would recommend the installer, and it will automatically install LÖVE to your program files. Honestly, that's basically it. I would recommend having a shortcut available on your desktop, as it'll come in handy soon when we actually start creating our first project. LÖVE is a pretty simple program to work with, and the reason I say this is because there is no interface to deal with or an editor that takes time getting used to. In fact, a completely viable way of programming with LÖVE is to do all of your programming in a text editor. But if you want my opinion on the best way to work with LÖVE, is to use Atom. Now, if you haven't heard of Atom, it's a highly customizable text editor that was built with programmers in mind. Anyone is capable of writing up their own add-ons for Atom, kind of like extensions with Chrome, and you can add these modules to make the editor more suited towards you. And this is good for us because there just so happens to be a few modules that help with making games for LÖVE. I should add that this is completely optional since you can just program in any text editor, so you can skip to the next lecture if that's what you want to do. But if you want a bit more convenience when you're programming, I'd recommend going to atom.io, then click on the download link, and then install a program. Then once it's installed, go ahead and open it up, and you should see something that looks like this. Yours will probably look a bit more bare than mine because I already added a few add-ons. Let's go ahead and get the LÖVE package installed to Atom. We can go up here to Atom, Preferences, or if you're on Windows, I believe it's File, Settings, and then it'll bring up the Settings tab. And we'll go down to Install, and the package we'd like to install is called LÖVE-IDE. And if we search for that, the very first hit should be the one that we want. So go ahead and hit the install button. While it's installing, it might ask to install dependencies as well, and a message will appear in the upper right corner of your screen. So just say yes whenever that happens. When it's done installing, you'll want to go to Packages and then search through our packages for LÖVE-IDE. When it pops up, you'll want to click the Settings button. It'll show us a few different things that will be worth looking at, the most notable of which is this. This is the path to the LÖVE executable. You may have noticed that when LÖVE-IDE was done installing, this little play button up here appeared. What this does is whenever you click on it, it'll run LÖVE. But before that will work, we first need to define the path to LÖVE on our computer. It even gives you hints up here for where the program is based on your operating system. If you're on Mac, it should be this path, and with Windows, this should be your path. This times 86 refers to whether or not you're using the 32-bit version of LÖVE. So if you download the 32-bit version, keep the times 86, but if you're using the 64-bit version, then don't include that part. So once that's there, you can keep scrolling down if you'd like, and it'll list out all of the different features that this program comes with, and all of them are really excellent for what we'll be doing. You still won't have all the packages installed that I do, but that's fine because now you know how to install new add-ons for Atom. Feel free to go through and add whichever ones you feel would be useful, or you can wait until we actually start getting into programming and then find some packages then. So if you haven't already, Go ahead and run Love as it is by clicking on the shortcut, and you'll be greeted with something. It depends on your version of Love, but here I have Super Toast. What this screen means is that Love is running, but no game files are found. And that makes sense. Love needs some actual code from us, the programmer, before it can do anything. So once you're done watching this, go ahead and close it for now. So as you've noticed, Love doesn't actually have any kind of editor that it comes with. So it's not like Unity or GameMaker. Instead, it's up to the user to provide code for everything that occurs in the game. And after running it, you can see the game in action. Now I know that may sound scary not having immediate feedback on what the game looks like, but believe me, having this code-focused paradigm allows so much more freedom on the part of the user. And you'll see what I mean by the time we move along with the series. We're going to use outside tools in conjunction with Love in order to get everything accomplished in an easy way. Now this next part is very important. Games made with Love have a particular folder structure in order for them to work. Lucky for us, it's really easy and straightforward. First, you need to create a new folder, and you can call it whatever you want. I'm just going to call mine Game. Of course, a more descriptive name, like the name of your game that you're making, would be best, but for now it's okay. Now in this folder, we're going to actually start putting some code in. So what I'm going to do is I'm going to open up Atom, and in Atom, we can add a project folder and go to our desktop where we created our folder and choose Game. And you'll see that on the side, we can see our project, Game. Now if you right click and choose File, we can give it a new file. And this new file is going to be called main.lua. Make sure you give it the .lua extension in order to make it a Lua file. And in addition to that, main is also a very important component to this. It has to have this exact title. But once you have that, that's all you really need. This structure we have right here is a fully functioning Love game. So let's talk about how we actually run it. There's a few ways. The first way to take the game folder that we created on our desktop, and we can simply drag it onto Love. And when we do that, the game starts up. Now there's nothing there, it's just a black screen, but that's because we didn't add anything to the code. So we can close that, or the other way is in Atom. Since we made this play button, and we have it mapped to the Love executable, all you have to do is click the play button, and it's going to start the game. It's going to run our code through Love. Let's add a little bit of code into this file, just so we can have something show up on our game screen. So we're going to write function love.draw, and for now, don't worry about what this means. We'll discuss this. Love.graphics.print, and in here we'll have hello world between quotation marks. And make sure you put end at the end. And also don't forget to save, it's very important. So what this code will do is Love is going to print or draw to the screen the message hello world. And if we run the game, we can see that it does. Up in the corner, we get a little hello world message. And with this structure set up, we're ready to start programming. As I mentioned, Love utilizes the programming language Lua to do all the coding. If you haven't used Lua before, I recommend checking out my full course on udemy.com titled Lua Programming and Game Development with Love. This course features a full section discussing Lua, teaching you everything you need to know to start programming your own games. The whole course assumes no prior technical knowledge, so if you've never programmed before, it'll be perfect for you. But even if you do have experience programming, it'll be a great way to become more familiarized with the language, especially with the tricky concepts like tables, which are important data structures that are unique to Lua. There's a link to the course in the description, and using this link will automatically apply a discount code, so be sure to check it out. Let's go ahead and start developing our very first game with Love. We're going to start by making a very simple game, and this is what it's going to end up looking like once we're done. It's a very simple button pressing game. You have a timer at the top, it's counting down, and the goal is to press the red circle as fast as you can before the time runs out. And of course, it keeps track of the score at the top, and that's basically it. Although the game is very basic, it's an excellent game to get our feet wet with making games, because it covers most of the basics. By the end of this video, we will get through most of the functionality for this game. Finally, we're going to start programming our first game. First things first is we need to create our project folder. So go ahead and create a new folder, and you can name it whatever you like. I'm going to name mine Button. And once that folder is created, we're going to go ahead and open up Atom. And then we need to add that project folder to Atom. And that's this one. Then once that's added, we need to make a new file. And remember, it needs to be called main.lua in order for our game to function correctly. So, just to make sure this works, if we click Run, Love opens up, but it's just a black screen because we haven't added any code yet, so that's good. Now, whenever I start a new game with Love, I always start by putting in the three main functions that make our game work. And that is the load function, the update function, and the draw function. Let's go through these one by one. First, we got love.load. This is what this function will look like in our code. Since we see this function has love in it, it's clear that we are going to start working with the features of love that the engine has to offer. For this function in particular, it's going to run the moment the game starts. So whatever we put in here is going to execute immediately when the game loads. And it's here that we're going to specify our global variables, adjust the window size, and perform any other preliminary setup before the game fully starts. The next function we have is love.update. Now you'll notice this one is a little bit different because it has a parameter, dt. dt stands for delta time, but you don't really need to worry about what that means right now. We'll get into that a bit more as the game moves along. Love.update is going to be our game loop. In other words, this function is going to be called every frame that our game is running. Since by default, games made with Love run at 60 frames per second, that means that the code inside love.update will be called 60 times every second. Finally, we have our love.draw function. As the name implies, this function is used for drawing graphics to the screen. Basically, anything that the player sees on their screen is going to be a result of something that happens inside this function. Draw is actually sort of similar to love.update because it runs every single frame as well. However, it is important to remember that draw is reserved for anything involving graphics or images. You shouldn't perform any calculations or declare any important variables here. Let's do a simple example to help you get a better understanding of how these three functions interact with each other. In the load function, let's make a new variable and call it number. Go ahead and set it equal to 0. Since this variable is declared in the load function, that means that this variable will exist from the moment that the game starts. Next, in the update function, let's increase number by 1. Now, since this line of code exists in the update function, that means that every frame that the game is running, the value that number contains is going to increase by 1. And finally, in love.draw, we're going to write the following line. love.graphics.print, and then we're going to pass it number. Keep in mind that this is the same line that we were using before when we were doing our programming lessons. So if we run our game, up in the corner, although it's small, we can see that the value that we're printing out is quickly increasing. It's the value of number. Every frame, it increases by 1. And since your game should be running at 60 frames per second, it's increasing by 60 every single second. This whole process that we just went through is pretty much how Love games work. Major variables are declared in the load function, the variables are altered during the update function, and using those values, something is drawn to the screen. In this case, number was initialized in load, it increases during the update, and the value is drawn to the screen. With this fundamental concept understood, we are ready to move on. In order to slowly introduce ourselves to how drawing graphics works, we're going to only use basic shapes in this game. Let's start by first getting rid of all the stuff we had in the functions before. Now we're going to take a look at the draw function. As I mentioned in the previous lecture, it is in here that any drawing functions go. Let's start by drawing a basic rectangle. To do this, we're going to use the function love.graphics.rectangle. This is a function that love includes for us that when we use and draw allows us to draw a rectangle. Now this function has several parameters that we'll need to take care of, and I'll explain what each of them means after we type them in. The first parameter is what's called the mode of the rectangle, and there's two options, filled or outline. And we want our rectangle to be filled, so we'll put fill in here. The next two parameters are the position on the game screen that the rectangle will start. In other words, it'll be the upper left-hand corner of our rectangle. So we'll start by putting it at 0, 0. Next is the width and the height of the rectangle. So I'm going to make the width be 200 and the height be 100. And that's it. With this function in place, we should expect a rectangle to be drawn to the screen. So when we run, we see in the upper left-hand corner, we have a white rectangle. It's a direct result of all the stuff we put into this line. As we specified in the function, our rectangle is filled and not just an outline. We could change this to line, for example, and save and run, and now our rectangle is just the outline of the rectangle. The 200 and the 100 are the width and height parameters. We can see this when we run the game. Our rectangle is twice as wide as it is high, and that's because we specified the width to be 200 and the height to be 100. Like I mentioned, it's in pixels, so it's 200 pixels and 100 pixels. And finally, the 0 and the 0 are the x and y coordinates of the upper left-hand corner. And by x and y, I mean the location of the point in the game. Right now we have it set to be 0, 0, which is the upper left-hand corner of the screen. So this point right here in the upper left-hand corner, that's the coordinates 0, 0. The game world is one big grid, and every pixel on screen has its own coordinates, an x and a y value. If you remember from your basic math classes, x refers to the horizontal location on a grid, and y refers to vertical location. What might be a little bit different than what you may remember is that in love, y increases downwards rather than upwards. For example, if we wanted to find the pixel at coordinates 200, 400, we would look to the right 200 pixels and down 400 pixels. So let's try this out. Back in the code, we're going to change the position of the rectangle to 200, 400. So that means that the x value of our rectangle is 200 and the y value is 400. And when we run the game, our rectangle has clearly moved. Before it was in the upper left-hand corner, but now it has moved to the right 200 pixels and down 400 pixels. And that's this point right here, the upper left-hand corner of the rectangle, because that's where the position of the rectangle is. Note that the size of the rectangle didn't change. We didn't change the 200 or the 100 here. We only changed these two values. So the rectangle is the exact same size. It's also worth noting that when we specify the width and the height here, the width increases to the right, 200 pixels, and the height increases downwards, 100 pixels. That's what I mean when I say that the position of the rectangle is the upper left-hand corner. See, this is the position right here. Then it finds the width, 200 pixels to the right, and the height, 100 pixels down. And that's how a rectangle is formed. A great thing about Love is that it comes with so many helpful tools for us as programmers that makes our jobs easier, just like this rectangle function. And it's kind of the point of a game engine. It would take quite a bit more time and code in order for us just to get to this point, with one white rectangle in the game window. LÖVE offers so many functions and features that make game development much simpler. Take a look for yourself. Open up your internet browser and go to a search engine and type in LÖVE2D wiki. The first result you'll find is this page. This is the LÖVE wiki. There's all kinds of information about what LÖVE has to offer. But what you'll find most useful is this section on the side, the documentation. Here, every function that LÖVE comes with is outlined and explained thoroughly, so you'll always be able to figure out how something works and how to use it. For now, since we're focusing on drawing graphics, let's click on the section called LÖVE.graphics. Here is a huge list of all the options that this graphics module has to offer. If we look under the Functions section, we should find our LÖVE.graphics.rectangle function. And here, it outlines all the different parameters that were in the function and explains what each one does. Even if you scroll down to the bottom, it has some sample code here of how the function is used in real code. So if you're dealing with a function in LÖVE and you forget how to use it, just go to the wiki and search for the function. Or even easier, you can normally just type in LÖVE2D rectangle in Google or something, and the first result will be this page. Now the game we're working on right now involves clicking on circles on the screen. So let's go back a screen and find LÖVE.graphics.circle here. Before we use this function, let's take a look at the parameters. We got the mode, which is the exact same thing as the rectangle one. It's either filled or line. Then we have the X and the Y, which is the position of the circle, which in this case is the center of the circle. And finally, we have the radius of the circle, which is the size. Let's go back to our code and try it out. On a new line, let's type in LÖVE.graphics.circle, and we'll make it filled. We'll make its position 0, 0, and for a radius, let's do 100. And save, and let's run. Now we can see that there is a part of a circle up in the upper left-hand corner. And the reason we can't see all of it is because we define the center of the circle to be 0, 0. So a lot of the circle is just off screen. We can fix that by changing the position of our circle to be something like, 100, 100. So now we have 100 for the X value, 100 for the Y value, and also 100 for the radius of the circle. So when we run, we can see the full circle in all its glory. And also notice that our rectangle is still being drawn to the screen because we left the rectangle function call still in here. In the next lecture, we're going to give a little bit of color to these shapes, and we're going to talk about what happens when these shapes overlap with each other. Looking at just a black and white screen is getting kind of dull, so let's add some color. In programming, at least in most cases, color is defined by using a color model called RGB, which simply stands for red, green, and blue. These are your three primary colors. And if you ever took an art class at some point, you knew that by mixing these colors together in certain ways will yield different colors. In fact, every color can be represented by some combination of these three primary colors, which is why programmers like to use RGB because they can precisely get the exact shade that they are looking for. In LÖVE, there's a really handy function called LÖVE.graphics.setColor. Feel free to look up this function in the documentation for more detailed information, but basically, it accepts three parameters, one for red, one for green, and one for blue. Each of these colors will be given a value from 0 to 255, 0 being none of that color, and 255 being as much as possible. For example, if I did the combination 0, 0, 255, that would mean that we're giving 0 red, 0 green, and full blue. And we can see this since we call this setColor function and we gave it parameters. These two shapes down here will be affected by that. So when we run, our shapes are now blue because the RGB scheme that we specified was just blue. I need to interrupt the lecture real quick to talk about how LÖVE was updated in version 11.0, where some of the stuff I just talked about isn't entirely accurate anymore. Like I just mentioned, originally, color values were integers in the range of 0 to 255. In versions of LÖVE that are 11.0 and later, this is no longer the case. The range is now decimal values from 0 to 1. This course was filmed using LÖVE version 10.0, so I'll be using the old scheme of 255. But for you, you should use the 0 to 1 scheme if you're on 11.0 or later. For example, if I ever write 255 in one of these color functions, you should simply write 1 instead. If I were to write in, say, 180 for one of these values, you can simply divide 180 by 255 to get roughly 0.706, and you would write that instead. Sorry for the inconvenience on the subject. In this lecture, I only use 255 values, so just remember to replace those 255s with 1s. So once you call this setColor function, that means everything after it in the draw function is going to be affected by it. So since we set the color to blue here, that means both the rectangle and the circle are going to be affected. But if we put in another setColor, love.graphics.setColor, and we put in 255, 0, 0, then that means we're now setting the color to red because we specified 255 red, 0 green, and 0 blue. So if we run now, we should expect to see this circle is red and the rectangle is blue, because here we set the color to blue, then we draw the rectangle, set the color to red, and draw the circle. Now here's a question. What would happen if these shapes were drawn at the same location? What if the rectangle was actually drawn at the same place as the circle? Let's test it out. In our code, instead of drawing the circle at 100, 100, let's draw it at 150, 350. Based on that location, the circle should overlap the rectangle a little bit. So let's run. We can see that where the circle overlaps the rectangle, the circle is on top. Now, why is the circle on top and the rectangle on the bottom? And that has to do with the draw order. We drew the rectangle first, and then we drew the circle. If it was the other way around, then the rectangle would be on top. This is because drawing on the screen is kind of like drawing a painting on a canvas. If you draw a rectangle somewhere on your canvas, and then you draw a circle afterwards, a circle is going to be on top, of course, because you drew the circle afterwards. It's important to be mindful of what order you draw things in, so the graphics don't get drawn over each other. So in this game, there will be a circular button that appears on the screen, and then the player will have to click on it as fast as they can. Once they click on it, it will reappear at a different spot on the screen. Each time they click, their score goes up. In order to easily coordinate all this, we're going to create a button table that stores a few values for us. If we keep all the values related to the button in one table, it'll be easier to manage and remember where everything is stored. So in order to do this, we're going to initialize our table in the load function. As you may remember, the load function executes immediately when the game begins, so this is the perfect spot for us to put this table. We'll go up here and we'll write button equals 2 curly braces. This is the table that we'll refer to whenever we want to talk about this main circle button. Now, the button needs to have a position, so let's go ahead and give it a button.x, start off at 0, and button.y equals 0. So now the button has an x and a y coordinate. Another thing this button needs is a size. So we'll put button.size equals 50, we'll say. And this about covers all the main aspects of our button. So let's go down to the draw function and use these values to actually draw this button that we just created. We'll use this graphics dot circle that we already had. So we do want the button to be filled, but we don't want these three parameters that we have right now. What we want to do is use these values up here. So remember, this first value is the x coordinate of the circle that we're drawing. So we're going to put button.x. This next value is the y coordinate, so we'll put button.y. And this last thing is the radius, so we'll put button.size. See, we have the button object up here, and all of these values associated with the button table are going to be used here when we're drawing the circle. So essentially, this draw function, or this circle function, is drawing our button for us. So when we run, we can see our button right up here. It's in the corner because its position is 0, 0. But we can change its position to whatever we want. Let's say 200, 200. Now we can actually see our button. But regardless, it's now being drawn to the screen. Now to wrap this lecture up, let's put some global variables into this game. For this game, we need to have a score. So we'll have a score variable up here. And we'll have a variable that keeps track of the time, so timer. We'll refer to these two variables whenever we're talking about the score or the time. When we click this button, we want our score to increase. Let's go through how to do this. First, we want to easily be able to know what our score is. So let's print out the score value to the screen so we can see it. We'll do this using the same function that we were using before, love.graphics.print, and in here we're going to put score. Now, when we run the game, there's a few things that you might notice. First of all, the score is super small and you can hardly even see it, and second, it's red. So let's first fix the red problem. Remember how I mentioned that when you call this setColor function, it affects everything after it? Well, that's our problem. So what we need to do is we need to set the color again here, and we'll put in white, which is the most visible color on our black background. So we'll do 255, 255, 255, which is white. White is what you get when you get full values for RG and B. Next, to address the text being too small, we'll need to change the font. So up in the load function, we're going to create a new variable called myFont. And we need to set it equal to love.graphics.newFont. And this myFont variable isn't really a variable because we're setting it equal to a new font. This is a function that creates new fonts for our games. And this function takes a few parameters. One thing about functions that we haven't really talked about yet is how there are oftentimes optional parameters. For example, in this function, a required parameter is the font size, but an optional parameter is the file name of the font file, such as OTF or TTF. We don't need to worry about providing font files since the default font that LÖVE uses is just fine. So the only parameter we need to put in here is the font size. I'll make it 40. Remember, all this information about this new font function is in the LÖVE2D documentation. There you can view all the different parameters that this function could take and get a better feel of what you can use to specify your different fonts. So now that we have our font object, we need to actually set the font. To do this, we use the function love.graphics.setFont. And the parameter for this is just the font we want to set to, which is myFont, the font that we just created. So now, anything that uses the print function after this line will utilize myFont. And to verify that works, it is. The font is now much bigger because it's using this new font, or myFont, that's of size 40. And the text is white because we use the setColor function here. So all the problems are now fixed with that. Now that we can clearly see our score at the top, we're going to go through and see how we can click on the button. We're going to be using LÖVE's mouse press function. If we go to LÖVE's wiki page, we can find all the information we need to know about love.mousepressed. The way we use this function is a little bit different from the others, and you'll see what I mean in just a moment. What we're going to do is simply copy this function definition right here, and we're going to go back to our code, and we're going to paste it at the bottom, like this. And don't forget to add the keyword function. You have to have that there in order for this to work. Now the reason we did a copy and paste with this one is because we're not going to be changing these parameters. We're going to leave them the exact same as they were. And that's why this function is a little bit different. What we're doing is we're overriding this function, which just means that we're changing how this mouse press function works whenever it's called. That's what these parameters are going to help us with. Whenever we click a button on the mouse, that's what causes this function to be called. When that happens, these parameters change to the certain values that are accurate to what's going on right then. The x is the x-coordinate of where the mouse was on the game screen when we clicked. The y is the y-coordinate for the same situation. The button is which button on our mouse was pressed when this function went off. The left click, right click, or the mouse wheel. And finally, this isTouch parameter is used for mobile development, and it lets us know if the user touched the screen in order to conduct this mouse press. Because in mobile development, they're basically the same thing, mouse presses and touches. This just verifies which it was. But for now, we don't really care about that because we're not working with mobile at the moment. So now that we have this function in place, let's go ahead and add some code to it. The first thing we should do is check to make sure that the button that was clicked on the mouse was the primary left click. So to do this, all we need to do is do a conditional statement to check for that. So we'll say if button is equal to 1, then. So what this if statement does is it verifies that button, when the mouse was pressed, is equal to 1. And if we go to the documentation on this button parameter that we're working with says that 1 is the primary mouse button. So by checking to verify that button is equal to 1, that's basically checking to see that the button that was pressed on the mouse was the left button, which is what we want. Inside this conditional statement, we'll need to test to see if the mouse was located inside of the circle when the mouse button was pressed. That way, the button is only clicked whenever the mouse is hovering over it. So we left off in the previous lecture by testing to see that the mouse button that was clicked was the primary left button. We did that by testing to see if button is equal to 1, because 1, when it's from this parameter button, means left click. Now there's something that we need to account for, is that this parameter has the keyword button, but up here we have the same word button. So to avoid any confusion, it would be a good idea if we changed this to just B, for example. We can change it to anything. So now whenever we want to refer to this button parameter, we just need to say B instead, and that means the exact same thing as before. And that's the beauty of parameters, is that you can redefine the names to be anything you want, and it's important to always make sure you have distinctions between the parameters and any keywords that you defined earlier in your program. So now inside of this if statement, this is where we're going to test to see if our mouse is inside the button. So when we click, then that means the button is underneath the mouse. And to do this, it's going to require a little bit of math to figure out. If we have the mouse's position and we have the button's position, how can we verify that the mouse was located inside of the button's circle? In other words, how can we make sure that the mouse is inside the button when it clicks? Because of course, if we're clicking on the button, the mouse has to be over top of it in order for the click to count. So we know with the button the button's XY value is right here, right in the center of the button. And the other important information is the radius of the circle, which is the distance from the center of the circle to the edge of the circle. With all this information, it might be easiest to measure how close the mouse is to the center of the circle. We have 2 points here. We have the button's point, and we have the mouse's point. If the distance between these 2 points is less than the radius, then that would mean that the mouse is inside the circle's perimeter. For example, if the mouse is here to the right of the circle, the distance between the center of the circle and the mouse is larger than the radius, since the radius is only from here to here, and the distance from the mouse to the button is from here to here. Clearly that difference is much bigger. But if, say, the mouse was here, the distance between the mouse and the center of the circle is less than the radius. The radius is this big, and if our mouse is inside that range, then we know for sure that the mouse is inside the circle. So with that information, we're going to have to utilize the distance formula, which, if you remember from your math classes, measures the distance between 2 points. And we can use that to know whether or not the mouse is inside the circle. So the distance formula looks like this. D is the distance calculated, and we have 2 points, each with an x and a y value. So that's where this x1, x2, y1, y2 comes from. The first point has an x1, y1, and the second point has an x2, y2. So we could say that the circle utilizes x1 and y1, and the mouse utilizes x2, y2. And if we use those values in this formula, it'll return the distance between those 2 points. So all we need to do is we need to implement this equation into our code so that we can plug in those values and get the actual distance. Unfortunately, there's no function built into Lua or LÖVE that calculates the distance between 2 points. So that's why we have to write our own function for this. So we're going to write function distance between, you can name this whatever you want, and we need to give it 4 parameters. We need to give it an x1, y1, x2, and y2, just like it does in this function here. So we're going to write in x1, y1, x2, and y2. And don't forget to put this end at the bottom, like all functions need. Now inside this function, we're going to use these parameters that we defined in order to perform this formula. Now that might be a little bit tricky because this isn't something that you can just easily type into your code. It has a square root symbol, it has the power of 2, so let's go through how we can do this. First, we need to handle the square root. Lua comes with a function called math.squareRoot, and that's how you do the square root. Anything that is between these parentheses is going to be square rooted. So all we need to do is we need to put all this stuff that's underneath the square root inside these parentheses here. So for example, if we put 4 in here, it would calculate the square root of 4. Or if we put x1 plus y1, it would calculate the square root of x1 plus y1. But we don't want to do that, we're just going to enter in what the distance formula needs. So let's just do this step by step. If we look at the distance formula, it starts with this, y2 minus y1 to the power of 2. So let's get started with that. We're also going to use the parentheses for this, y2 minus y1. Now we need to take this to the power of 2, because that's what it does in the formula. And luckily for us, this isn't too hard, because Lua comes with this character. All we need to do is caret 2. That's the same as saying to the power of 2, which is what the formula does. Now let's move on. Next we need to add x2 minus x1. And again, this is also taken to the power of 2. And that should be it. If we compare what we have here inside the parentheses of the square root, it should match what we have here in the distance formula. So essentially, this calculates the distance between this point, x1, y1, and this point, x2, y2. Now all that's left is we need to return it. So we just write return all of that. So, although it was a little bit tricky, we just wrote the distance formula as a function that accepts 2 points, point 1 and point 2, and it does this big calculation and returns it. So that's all we need to do for that. Now that we have this function all ready to use, we can go back to our code inside the mouse press function, and we're going to utilize that function when we're testing to see if the mouse is over top the button. To do this, we'll need another if statement. So we're going to write an if statement inside of an if statement. We call that a nested if statement. So we'll write if, and the next thing we need, of course, is the distance between the mouse and the button. To do that, we're just going to call our distance formula function. Distance between. Now, we wrote it so that we need to pass it parameters. And those parameters are the x and y values of the mouse and the x and y values of the button. So we're going to start with the button. It doesn't really matter which is which. We'll do button.x and button.y. So these two values are going to correspond to these two. Next we need the mouse's x and the mouse's y. Now we can't just do mouse.x because we didn't specify a mouse table anywhere and this mouse.x doesn't really exist. Instead, love comes with a function that we can use that gets this value for us. It's called love.mouse.getx and also love.mouse.getY. So with all these parameters in place, this whole line should calculate the distance between the button and the mouse. Next, we want to check and see that that value is less than button.size, or the radius of the button. And we'll write then and end. That was a lot of work. I understand that it was a lot of information at once, so if you're a bit unsure of what we just did, I encourage you to go back and watch that process again, just to get a better handle of how we did this. But once you're ready, let's go ahead and finish this up. We now have an if statement inside of an if statement. And how this will work is first it'll go to this first if statement. If the button is equal to 1, or in other words, if the player clicked their left button, then it's going to move on to this one. And remember, this if statement checks to see if the distance between the button and the mouse is less than the radius of the button. Or in other words, is the mouse over top the button's circle? And if it is, we want score to increase by 1. And that should do it. With everything in place here, when we run the game, and we click inside the button, our score goes up. And notice that if you click outside the button, nothing happens anywhere you click. It only works if you're inside the button itself. And that's because we're checking to see if the mouse is located over top the button. Also note that if you try to right click, it doesn't work. That's because we made sure in this line right here that the player was using their primary left button in order to do that click. So none of the other buttons work for this. In the final game, we want to make it so that when the player presses on the button will jump to another position on the screen. Let's implement that now. The code we're going to write is going to go right in here where the score increases. All we need to do is change button.x and button.y to different values. Let's try a basic example. Here we'll set button.x to 500 and button.y to 400. Now those are different values to what they were initialized to, so when we click on it, the button should jump to a different position. So we click, and the button moves. But it doesn't last long because it's just going to keep jumping to 500, 400 every time we click. It's not going to change after that. So what we want to do is add a little bit of randomness to this. Lua comes with a math.random function. Using this, we can generate a random value, and we can assign this value to the coordinates of the button. This would put it into a random, unexpected position. Now there are several ways to use this function, but the best way to do it with this particular situation is to provide a minimum value and a maximum value. For example, we could write 0, 20, and that would mean that this line would generate a random value between 0 and 20. More specifically, it'll generate an integer between those values. This can be applied very well to what we're doing. Go ahead and start the game. We want the x value of the button to jump to a random value between 0, the left side of the screen, and the right side of the screen. So we need to figure out what the width of the screen is, and then just make the random value generate between 0 and the width. And the same applies to the height with the y value. We want y to be between 0, the top of the screen, and whatever the height of the screen is at the bottom. So let's figure that out right now. So first let's take care of the x value. We'll first set x to be math.random, and like I said, we want this range to be from 0 to whatever the width of the screen is. And we can actually get that because LÖVE provides a function called love.graphics.getWidth. And this just returns in pixels the width of the screen. So essentially, let's say the width of the screen was 1000 pixels. It would return an integer between 0 and 1000, which is exactly what we'd like. It'll put the x position of the button somewhere randomly in between the left side of the screen and the right side of the screen. And we're going to do the exact same thing for y. We're going to do math.random 0, love.graphics.getHeight this time. And it works the exact same way, from 0 to whatever the height of the screen is. And that takes care of that. If we run the game, every time we click, the button is going to be in a different position on the screen somewhere, which is exactly what we want. There is actually one small exception we need to account for. If we keep clicking, you'll eventually see like this. The button goes off screen a little bit. And that's because we decided to make the range be from 0 to the very edge. So it could potentially be right on the edge, the center of the circle. And we actually don't want that because we get situations like this where the circle is partially off screen. What we should do is make it so the position is between the radius of the circle and the height minus the radius. This would mean that the center of the circle would always be a radius length away from the edge of the screen. So we wouldn't ever get this situation where it's off screen at all. So how about instead of 0 right here, we just say button.size. And let's do that for y as well, button.size. And for the width and the height, what we're going to do is we're going to subtract button.size. This will keep it from getting too close to the edge. And that should fix that. Now if we keep clicking, it'll never get too close to the edge. This is about as close as it'll get, because the center of the circle can only get as close to the bottom as the height of the screen minus the radius of the circle, which is about right here. That about wraps up this introductory tutorial of LÖVE2D. Congrats on making it all the way here. However, we've only scratched the surface of what LÖVE has to offer. We discussed the core, basic features here, but there is so much more to learn. If you'd like to dive deeper into this framework, be sure to check out my full course on udemy.com called Lua Programming and Game Development with LÖVE. This course features all the footage from this video, but with so much additional content, coming to a total of more than 5.5 hours of video lectures. In these lectures, we will continue on and finish this button-clicking game by implementing the timer, adding a main menu, and polishing up the game in general. Following that, we will move on to complete 2 more fully completed games with LÖVE, the first being a top-down shooter, and the second being a platformer. We go over so many important topics in these videos, including drawing sprites, getting keyboard input, making a character move, rotating graphics, adding enemies and projectiles, implementing a camera, using the physics engine, adding animations, using tiled to design levels, and saving and loading data. After going through all these concepts, you will be fully ready to create your own games with LÖVE. If you're interested, there's a link in the description of this video to the course. Using this link will automatically apply a discount code, so look it over and see if it's something that you'd be interested in. All Udemy courses come with a 30-day money-back guarantee, so there's no risk in giving the course a try. If you have any questions, leave a comment on this video. And if you enjoyed the content here, be sure to hit the like button. Thanks for watching this tutorial, and I look forward to seeing you in the next one.